We need to talk about a threat that doesn't come from space, not from distant stars or wandering black holes or solar fury. We need to talk about something that could form right here, right beneath your feet, in the depths of Earth itself. A black hole. Not fallen from the cosmos, but born from the planet. Not massive, but microscopic. Not created from collapsed stars, but from concentrated energy reaching densities that shouldn't be possible, that physics says can't occur naturally, but that might occur anyway through processes we don't fully understand. This is the Kugelblitz scenario. The spontaneous formation of a black hole from pure energy, from radiation so concentrated that space-time itself collapses under the intensity, creating an event horizon not from mass but from light trapped by its own gravity. It's theoretical, speculative, based on equations that describe regimes of physics we've never directly observed. But the mathematics is sound. Einstein's equations allow it. Quantum field theory predicts conditions under which it could happen. And if it happens, if a Kugelblitz forms inside Earth, even a microscopic one, the consequences would be unlike anything humanity has ever faced. Because this black hole wouldn't orbit harmlessly in space. It wouldn't pass us by after a gravitational encounter. It would be inside the planet, embedded in rock and metal, accreting matter at a steadily increasing rate, growing, sinking toward the core, and eventually consuming Earth from the inside out. You wouldn't see it coming. There would be no warning signs in the sky, no advanced detection, no time to prepare, just subtle anomalies deep underground that no one would notice until it was far too late. Let's understand what we're facing. Let's map the physics of internal annihilation before we contemplate whether we should fear it. A Kugelblitz is German for ball lightning, but in physics it means something far stranger and more dangerous. It's a black hole, created not by the gravitational collapse of matter, but by the concentration of radiation, photons, electromagnetic energy, to such extreme densities that the energy itself curves space-time enough to form an event horizon. Einstein's equations are clear on this. Energy and mass are equivalent through E(mc)2. Both contribute to space-time curvature. Both can create gravity. And if you concentrate enough energy in a small enough volume, you get the same result as concentrating enough mass, a black hole. The threshold is extraordinarily high. To create even a microscopic Kugelblitz, you'd need to concentrate the energy equivalent of a significant fraction of the Sun's mass into a region smaller than an atomic nucleus. That's energy densities billions of times higher than anything in stellar cores, higher than anything that occurs naturally in the universe today. At least we think it doesn't occur naturally. The early universe, in the first moments after the Big Bang, had energy, densities high enough to spontaneously create black holes. Primordial black holes, ranging from microscopic to stellar mass, might have formed in those first seconds and could still exist today. But in the current universe, with its relatively low energy density, Kugelblitz formation shouldn't be possible through natural processes. Shouldn't be. But there's a difference between what should happen, according to our current understanding, and what actually happens in regimes of physics we've never directly tested. The concern, the nightmare scenario that keeps some physicists awake at night, is that there might be natural processes we don't understand. Quantum fluctuations, vacuum instabilities, interactions between dark matter and normal matter that could create localized regions of extreme energy density. And if such a region formed inside Earth, if quantum uncertainty or unknown physics conspired to concentrate energy beyond the Kugelblitz threshold even for a fraction of Earth. Second, a microscopic black hole would nucleate, and once nucleated, it would persist. Here's where it gets truly terrifying. A Kugelblitz, once formed, doesn't need to maintain extreme energy density to continue existing. The event horizon is self-sustaining. The black hole is stable. It will persist and grow, accreting whatever matter it encounters, following the same physics as any other black hole. And if it forms inside Earth, it encounters a lot of matter. Let's walk through what would happen, step by step, as a Kugelblitz forms in Earth's interior and begins consuming the planet from within. Day 0. Somewhere deep in the Earth, perhaps in the mantle, perhaps near the core mantle boundary, a quantum fluctuation occurs. Not a simple fluctuation, those happen constantly, harmlessly. But a rare, extraordinarily improbable fluctuation that concentrates energy to Kugelblitz forming densities. For a fraction of a second, a region of space smaller than a proton contains energy, equivalent to millions of tons of matter. Spacetime curves violently. An event horizon forms. A black hole is born. It's tiny, unimaginably tiny. If it has the mass of a small mountain, say 1 billion tons, its event horizon would be about 10 to the power 18 meters across. That's smaller than an atomic nucleus, smaller than a quark. At this scale, quantum effects dominate, and our understanding of physics becomes uncertain. But even at this microscopic scale, it's a black hole. It has an event horizon, it has gravity, and it begins to accrete. The accretion is slow at first. The black hole is so small that matter has to get extraordinarily close to fall in. But Earth's interior is dense, rock, metal, compressed by the weight of thousands of kilometers of planet above. Matter surrounds the Kugelblitz. Atoms near the black hole experience tidal forces, not strong enough to be noticeable at planetary scales, but strong enough at atomic scales to distort electron orbits, to stress molecular bonds. Some of this matter falls in, crosses the event horizon, adds to the black hole's mass. The black hole grows, imperceptibly at first, adding a few atoms per second. But growth is exponential. The more massive it becomes, the larger its event horizon, the more matter it can capture, the faster it grows. Day 1. The Kugelblitz has accreted the equivalent of a small asteroid's mass. Its event horizon is now 10 to the 15 meters across, still subatomic but growing. Its gravity is pulling in matter from a slightly larger radius. Growth accelerates. There are no surface effects. No one on Earth notices anything unusual. Deep in the planet's interior, in regions no human has ever visited or will ever visit, a black hole is consuming matter, but the scale is still too small to affect anything measurable from the surface. Week 1. The black hole has reached the mass of a small mountain. Its event horizon is 10 to the 12 meters, still microscopic but approaching the scale of large molecules. It's accreting thousands of tons of matter per second, growing at an accelerating rate. It's also moving, not orbiting. Its formation was random, not in any particular trajectory. It's responding to Earth's gravity, sinking toward the center of mass, toward the core. As it moves through the mantle, it consumes everything in its path, leaving a void, a tunnel of non-existence tracking through solid rock. The void collapses behind it. Rock flows into the tunnel, is consumed, creates more void. The process is self-sustaining, self-accelerating. Still no surface effects. The Earth is vast. A tunnel a few meters across, thousands of kilometers down, doesn't affect the surface. Seismographs detect nothing. Satellites measure no gravitational anomalies. Life continues normally above, while below, the planet is being consumed from within. Month 1. The Kugelblitz has reached the mass of a large asteroid. Its event horizon is now measurable in millimeters. It's consuming millions of tons of matter per second. The void it's creating is significant. A cylindrical tunnel dozens of meters across, extending through the mantle as the black hole sinks toward the core. And now, finally, there are effects we can detect. Seismographs worldwide are registering strange signals. Not earthquakes, the signatures are wrong, but deep rumbles, low-frequency vibrations from the planet's interior, patterns that don't match any known geological process. Geophysicists are puzzled. The signals are coming from depths where nothing should be moving. where rock is too plastic, too compressed to generate the sharp seismic signals associated with earthquakes. Some researchers propose a new theory. Maybe it's related to core convection, to magnetic field dynamics, to processes we don't fully understand. They're right that it's something we don't understand, but they're wrong about what it is. It's a black hole, sinking toward Earth's core, consuming the planet from within, and it's accelerating. Month 3. The black hole has reached the mass of a large moon. Its event horizon is now meters across. It's consuming billions of tons of matter per second. The gravitational disturbance is becoming measurable from the surface. Satellites monitoring Earth's gravity field detect anomalies, a localized region where gravity is slightly stronger than it should be, and the anomaly is moving, sinking deeper into the planet. The data is confusing. Gravity doesn't just move like this. Gravity is a property of mass, and mass in Earth's interior doesn't relocate on timescales of months. Unless something is concentrating mass, pulling it inward, consuming it. Some physicists start to suspect the truth. The pattern matches theoretical predictions for a black hole inside the planet. But it seems impossible. Black holes don't just appear in planetary interiors. There's no mechanism, no process that could create one. Except there is. The Kugelblitz scenario. Quantum. Fluctuation creating a region of extreme energy density, forming an event horizon, beginning the process of runaway accretion. It's theoretical, speculative. The probability should be negligible, but the data doesn't lie. Something massive is inside Earth, growing, sinking, consuming matter at an accelerating rate. And if it's a black hole, if the calculations are correct, then Earth has months, perhaps a year at most, before the process becomes irreversible. Year 1. The black hole has reached the core. It's now consuming not just rock, but iron and nickel, the dense metals that make up Earth's core. Its mass is equivalent to a small planet. Its event horizon is kilometers across. The effects on the surface are undeniable now. Earthquakes are constant, global, as the planet's internal structure destabilizes. The magnetic field is fluctuating wildly. The core's convection patterns are being disrupted by the black hole's gravity, by the void it's creating as it accretes matter. The rotation rate of Earth is changing, not dramatically, not yet, but measurably. The black hole is consuming angular momentum along with matter, slightly altering Earth's rotation. Days are getting imperceptibly longer, and the planet is shrinking. As matter falls into the black hole, as mass is removed from the planet's interior and concentrated at a point, Earth's radius decreases. Millimeters at first, then centimeters, then meters. The surface cracks, continental plates shift, mountain ranges collapse, the ocean floor buckles, volcanism explodes worldwide as pressure differentials in the mantle trigger eruptions at every weak point in the crust. Civilization is collapsing. Not from the black hole directly. It's still thousands of kilometers beneath the surface, unreachable, invisible. But from the consequences, the earthquakes, the volcanism, the magnetic field fluctuations that destroy satellite electronics and induce currents in power grids, and the knowledge, the terrible knowledge that Earth is being consumed from within, that a black hole is in the core, growing, and there's nothing we can do to stop it. Let's talk about what we couldn't do, because that's the most horrifying aspect of this scenario. We can't destroy a black hole. Once formed, it's the most stable object in physics. You can't blow it up with nuclear weapons. The energy just adds to its mass. You can't dissolve it with chemicals. Chemistry doesn't affect event horizons. You can't unmake it with any technology we possess or can imagine possessing. We can't reach it. The Kugelblitz is in Earth's core, 6,000 kilometers down, in regions where pressure exceeds millions of atmospheres and temperature exceeds thousands of degrees. We've never drilled deeper than 12 kilometers. We have no technology to reach the core, let alone to deploy something there. We can't escape it. The black hole is inside our planet. We're on the planet. Where would we go? Mars? The journey takes months, and we can't evacuate billions of people. The Moon, it's too close. When Earth's mass drops enough, the Moon's orbit destabilizes, and it either crashes into what's left of Earth or drifts away into space. We can't stop the accretion. The black hole grows by consuming matter, and it's surrounded by matter, the entire planet. Every second, billions of tons fall into the event horizon. Every second, the black hole gets larger, its gravity stronger, its accretion rate faster. It's a runaway process, exponential growth. And once it started, once the Kugelblitz formed and reached stable size, the ending became inevitable. Earth will be consumed, completely. The black hole will accrete the entire planet, all 6x10^24 kilograms of it, over a period of months to years depending on the initial size and growth rate. And when it's done, when all of Earth's mass has fallen past the event horizon, what remains will be a black hole with Earth's mass and event horizon about 18 millimeters across, orbiting the Sun where Earth used to be. The Moon might survive, orbiting the black hole instead of the planet. Mars and Venus would be unaffected. The Sun's gravity still dominates at those distances. But Earth and everything on it, everyone who lived here, all of human civilization, all of terrestrial life, gone, consumed, compressed beyond the event horizon into a region of space-time so warped that our physics can't describe what happens there. This is the Kugelblitz nightmare. Not destruction from outside, but annihilation from within. The planet eating itself, or being eaten by a quantum accident at its core. Let's talk about probability now, because you're probably wondering, how likely is this? Should we actually be worried about Kugelblitz formation, or is this purely academic speculation? The honest answer is, we don't know. The probability depends on physics we don't fully understand, on quantum processes at energy scales we've never tested, on possible interactions between fields and particles that might not even exist. What we can say is this: based on our current understanding of quantum field theory and general relativity, the spontaneous formation of a Kugelblitz in Earth's interior is extraordinarily improbable. The energy fluctuations required are so far beyond anything that occurs in normal matter that you could wait longer than the current age of the universe and not expect to see one. But extraordinarily improbable is not the same as impossible, and our understanding has limits. We don't have a complete theory of quantum gravity. We don't know what happens at the Planck scale, where quantum effects and gravitational effects become comparable. We don't fully understand vacuum fluctuations, or whether there are instabilities in the vacuum that could create localized regions of extreme energy density. We especially don't understand what happens in the deep interiors of planets, where pressures and temperatures create conditions we can't replicate in laboratories. Could there be phase transitions in matter at extreme pressure that release energy in unexpected ways? Could there be interactions between the Earth's magnetic field and quantum fields that concentrate energy beyond expected levels? These are open questions. Most physicists would say the answers are probably no, that standard physics applies, and Kugelblitz formation is safely impossible, but probably is doing a lot of work in that sentence. And the consequences of being wrong, of there being some rare unexpected process that can create Kugelblitzes, are so catastrophic that even tiny probabilities are worth thinking about. There's also the question of whether we would even recognise a forming Kugelblitz before it was too late. The early stages would be invisible. A subatomic black hole deep in the mantle produces no detectable signals. By the time seismic anomalies appear, by the time gravitational measurements detect something unusual, the black hole might already be massive enough that the process is irreversible. We might get months of warning, we might get weeks, or we might get none, might only realise what's happening when the earthquakes become global, when the magnetic field collapses, when it's obvious that Earth is dying from the inside out. And even with warning, even with perfect knowledge of what's happening, we couldn't stop it. We could only watch, could only document the process as scientists do, could only try to understand our own annihilation as it unfolds. That's a special kind of horror. Not the horror of sudden catastrophe, but the horror of slow, inevitable destruction that you can observe, can measure, can predict with precision, but cannot prevent. Let's talk about what the experience would be like, living through the months or years as Earth is consumed by an internal black hole. The first signs would be seismic. Unusual, deep earthquakes, patterns that don't match any known geological process. Geophysicists would notice, would publish papers, would debate the cause. Then the gravitational anomalies. Satellites would detect a moving mass concentration in Earth's interior. The data would be confusing, impossible to explain with conventional geology. Someone would propose the Kugelblitz hypothesis. It would be controversial, dismissed by most as too speculative, too unlikely. But the data would keep coming, and the pattern would keep matching the predictions. Eventually consensus would emerge. There's a black hole inside Earth. It's growing, and we can't stop it. The public response would be complex, denial initially. Many people wouldn't believe it, couldn't accept it. A black hole inside the Earth sounds like science fiction, like a movie plot, not like reality. But the earthquakes would continue, increasing in frequency and intensity. The magnetic field would fluctuate more dramatically. Aurora would appear at the equator as the magnetosphere destabilizes, and scientists would appear on news programs trying to explain, trying to make people understand that this is real, that Earth is dying, that we have limited time. How would society respond to that knowledge? How would billions of people react to learning that the planet is being consumed from within, that there's no escape, that the end is coming in months or years? Some would panic. Violence, looting, the breakdown of social order as people conclude that nothing matters anymore, that law and consequence are irrelevant when everyone is doomed anyway. Others would retreat into denial, would continue their lives as if nothing is happening, would go to work and pay bills and make plans because accepting the reality is too painful, too overwhelming. Some would turn to religion, would interpret the Kugelblitz as divine judgment, as the end times, as prophecy fulfilled, would gather in churches and mosques and temples seeking meaning or salvation or simply community in the face of annihilation. And some would rage, would demand that governments do something, anything, even knowing there's nothing to be done, would protest, would riot, would lash out at the unfairness of dying not from their own mistakes or choices but from a quantum fluctuation in the planet's interior. Governments would try to maintain order, to keep infrastructure functioning, to preserve what they could of civilization for as long as possible, but it would be futile as the earthquakes intensified, as volcanism increased, as the planet's structure continued destabilizing. Normal life would become impossible. Food production would collapse. Transportation networks would fail. Power grids would fail. Water systems would fail. All the infrastructure that supports 8 billion people would break down, and there would be no point in repairing it because Earth itself is dying. The die-off would be massive. Not from the black hole, it's still in the core, not directly affecting the surface, but from the cascading failures, from the societal collapse, from starvation and disease and violence. Billions would die before the planet itself is consumed, and the survivors would face a choice. How do you spend the last days or weeks of Earth's existence? Some would try to preserve knowledge, would encode human history, science, art, everything we've learned and created, into signals beamed toward other star systems, messages in bottles thrown into the cosmic ocean, hoping someone, somewhere, someday might find them and know we existed. Others would focus on experience, would spend time with loved ones, would try to appreciate beauty, would seek meaning in connection and presence rather than in futile attempts at legacy. And some would work until the end. Scientists documenting the planet's destruction, gathering data, trying to understand the process even as it kills them. Not because the knowledge will save anyone, it won't, but because understanding is what scientists do even in the face of death. Let's talk about the physics in more detail, because understanding how a Kugelblitz could form helps us understand why it's so dangerous and so difficult to prevent. Einstein's field equations relate the curvature of spacetime to the energy-momentum tensor, a mathematical object that describes the distribution of energy and momentum in space. Mass contributes to this tensor. So does electromagnetic radiation. So does pressure. So does any form of energy. Normally, the energy density of electromagnetic radiation is far too low to create significant spacetime curvature. Light passes through space without creating black holes because the energy is spread out, diffuse, not concentrated enough. But in principle, if you could concentrate enough electromagnetic energy in a small enough volume, you'd create curvature sufficient to form an event horizon. The threshold is the Schwarzschild radius for the equivalent mass, r 2gmc2, where g is the gravitational constant, m is the mass equivalent of the energy via e rem-c2, and c is the speed of light. For a Kugelblitz with the mass equivalent of Earth, the Schwarzschild radius is about 9 millimeters. To create this from pure energy, you'd need to concentrate 1042 joules, roughly the total energy output of the Sun over several days, into a region smaller than a centimeter. That's an absurd energy density. Nothing in the current universe approaches it, except possibly in the most violent astrophysical events. Gamma-ray bursts, perhaps, in the immediate vicinity of the jets. But even there, the energy is moving, expanding, not confined to a small volume. So how could a Kugelblitz form inside Earth? 3 possibilities, all speculative. First, quantum fluctuations. At the quantum level, energy is constantly fluctuating. Virtual particles appear and disappear. The vacuum seethes with activity on scales too small and too brief for us to directly observe. Normally, these fluctuations average out, cancel out, produce no macroscopic effects. But quantum mechanics is probabilistic. Unlikely events happen occasionally. And while the probability of a fluctuation large enough to create a Kugelblitz is astronomically small, it's not zero. Over the lifetime of Earth, 4.5 billion years, over the entire volume of Earth's interior, 1021 cubic meters, you're rolling quantum dice an incomprehensible number of times, and eventually with enough rolls, even astronomically unlikely events occur. Second, unknown physics. We don't have a complete theory of quantum gravity. We don't know if there are additional fields, additional particles, additional interactions beyond the standard model. What if dark matter can interact with normal matter in ways we haven't detected? What if there are phase transitions in matter at extreme pressure that we haven't discovered? What if the vacuum has metastable states that can decay under certain conditions, releasing energy in concentrated bursts? Any of these hypothetical processes could, in principle, create localized regions of extreme energy density. And if one occurred in Earth's interior, the result could be Kugelblitz formation. Third, technological accident. This is more science fiction than serious physics, but it's worth mentioning. If humanity ever develops technology capable of manipulating energy at extreme densities, powerful lasers, particle accelerators, exotic matter creation, we might inadvertently create a Kugelblitz. This is one of the concerns that was raised about the Large Hadron Collider. Could it create microscopic black holes? The answer was no. The energies aren't high enough, and even if they were, microscopic black holes would evaporate via Hawking radiation faster than they could grow. But what about future technologies? What about experiments we haven't conceived yet? Using physics we don't yet understand? Could we accidentally create a stable Kugelblitz? Probably not. But the probability is non-zero, and the consequences would be catastrophic. Let's think about detection and prevention, because even if we can't stop a Kugelblitz once it's formed, maybe we could detect conditions that might lead to formation and prevent it from starting. The challenge is that we have essentially no ability to monitor Earth's deep interior in real time. Seismology gives us snapshots, tells us about large-scale structure, but can't detect quantum-scale processes or localized energy concentrations. We could, in principle, design detection systems, arrays of sensors deep in mines, in boreholes, monitoring for unusual energy signatures or gravitational anomalies. But even the deepest mines only reach a few kilometers down, a tiny fraction of Earth's radius. And what would we do if we detected something? If we found a region of unusually high energy density forming in the mantle, how would we intervene? We can't drill to it. Drilling to mantle depths is beyond current technology, and drilling to core depths is impossible with any conceivable technology. We can't detonate nuclear weapons there. We can't deliver them to depth, and even if we could, adding energy to a region that's already approaching Kugelblitz forming density would make the problem worse, not better. We can't do anything. We're spectators to processes occurring in regions of our own planet that we can't reach, can't affect, can barely even observe. This is humbling in a different way than cosmic threats. Gamma-ray bursts and asteroids are at least outside us, external threats we can imagine defending against or escaping from. But a Kugelblitz forms inside our planet, inside the very ground we walk on, and we're powerless to prevent or stop it. Let's talk about what happens in the final stages, as the black hole reaches critical size and begins consuming Earth rapidly. By the time the black hole has accreted a significant fraction of Earth's mass, say 10% or more, the planet's structure is fundamentally compromised. The mantle is riddled with voids where matter has been consumed. The core is partially or completely gone, replaced by the black hole. Earth's gravity at the surface is decreasing. Not dramatically, most of the mass is still there, just redistributed, but measurably. Objects weigh slightly less. The atmosphere expands slightly. The moon's orbit becomes unstable. The magnetic field is gone, completely. The core's convection, which generates Earth's magnetosphere, has stopped. We're exposed to solar wind, to cosmic radiation, to all the high-energy particles that the magnetic field normally deflects. Auroras appear constantly, globally. The sky glows with radiation. Electronics fail from the bombardment. Anyone outside receives dangerous radiation doses, and the planet is shrinking. Visibly, measurably shrinking as mass is consumed. The radius decreases by meters per day, then kilometers per day. The surface cracks, buckles, collapses into the voids beneath. Oceans drain into chasms. Continents fragment. The entire surface of Earth is in motion, sliding toward the center as the planet's volume decreases. If anyone is still alive at this point, and it's unlikely given the earthquakes, volcanism, radiation and societal collapse, they're witnessing something unprecedented in the history of conscious observation. A planet dying, being consumed from within by its own creation. The process accelerates. The black hole's event horizon is now kilometers across. It's accreting not billions but trillions of tons per second. Earth's mass is draining into the singularity at an exponential rate. Within days, the surface collapses completely. The remaining atmosphere follows. Any structures, any remnants of civilization, any survivors, all pulled toward the center, compressed, torn apart by tidal forces, consumed by the event horizon. Within weeks, Earth is gone, completely. All 6x, 10^-24 kilograms of matter, all the rock and metal and water and atmosphere, all the life and civilization and history, collapsed past the event horizon, compressed into a singularity we can't describe with current physics. What remains is a black hole, roughly 18 millimeters in diameter, orbiting the Sun at 1 AU. Possibly with the Moon still orbiting it, a faithful companion to a dead world. The Sun continues to shine. Mars and Venus continue their orbits. The solar system continues functioning normally, indifferent to the fact that one of its planets just ceased to exist. And if there are observers on Mars, if we'd managed to establish a colony there before the Kugelblitz formed, they would watch through telescopes as Earth disappeared, as the familiar blue-white marble was replaced by nothing, a point of darkness, a hole in space where a planet used to be. They would be the survivors, the only humans left, living on a world that's barely habitable, knowing they're the remnants of a species whose home was consumed by a quantum fluctuation in its own interior. What would they do? How would they continue, knowing what happened, knowing that the same process could theoretically occur on Mars or any other world? Would they give up, conclude that existence is too precarious, too vulnerable to random catastrophe to be worth continuing? Or would they persist? Would they choose to continue despite the knowledge of vulnerability? Would they build and create and hope that they can endure long enough to become a civilization distributed across multiple worlds, resilient enough to survive the loss of any single planet? Let's shift perspective now. Let's move from the mechanics of planetary consumption to the deeper philosophical implications of a threat that emerges from within rather than from without. There's something profoundly disturbing about internal threats, external dangers. Asteroids, solar storms, gamma-ray bursts come from outside. They're alien to us, separate, distinct. We can imagine defending against them, or at least we can imagine them as something other than ourselves. But a Kugelblitz would form from Earth itself, from the planet's own matter, energy, and quantum fields. It's not an invasion or an impact. It's spontaneous generation of destruction from the substrate of our existence. This changes the psychological relationship with the threat. You're not being attacked. You're not unlucky to be in the path of something external. The danger arises from the ground beneath your feet, from the planet you were born on, from the very foundation of your existence. It's like your body developing cancer. The cells are yours. The DNA is yours. The mutation happens internally, spontaneously, without external cause. And once it starts, once the malignant growth begins, stopping it is extraordinarily difficult and often impossible. Earth developing a Kugelblitz is planetary cancer, a rogue process emerging from normal, physics, growing exponentially, consuming the host from within, ultimately lethal. This metaphor is uncomfortably apt, and it raises questions about whether existence itself is fundamentally stable, or whether we're always one quantum fluctuation away from catastrophic failure. Consider, you're made of matter. Matter is made of quantum fields. Those fields are constantly fluctuating, constantly generating virtual particles, constantly exploring every possibility allowed by physics. Most of the time, these fluctuations are harmless. They average out, cancel out, produce no macroscopic effects. But occasionally, rarely, a fluctuation is extreme enough to have lasting consequences. A Kugelblitz is an extreme example, but there are others. Vacuum decay, which we've discussed before, is another. A quantum fluctuation that triggers a phase transition in the Higgs field, rewriting the laws of physics. Both scenarios suggest that reality is metastable, that the stable conditions we experience are temporary, contingent, vulnerable to rare quantum events that could suddenly and irreversibly change everything. This is unsettling because it means we can never be truly safe. No amount of preparation, no technology, no understanding can eliminate the possibility that tomorrow a quantum fluctuation somewhere in the universe or inside our planet triggers a process that destroys us. We're living on borrowed stability, in a universe where the rules allow for spontaneous catastrophe, and there's nothing we can do about it except hope that the probabilities remain in our favour. How do you live with that knowledge? How do you build a civilization, raise children, make long-term plans when the foundation could literally collapse into a singularity without warning? The same way you live with any profound uncertainty, by focusing on what you can control, by finding meaning in the present, by accepting that permanence was never guaranteed and proceeding anyway. Let's talk about the scientific response to Kugelblitz scenarios, because this threat, unlike many others, has received relatively little serious attention from the physics community. Part of this is because the probability appears to be extremely low. Without experimental evidence of Kugelblitz formation, without any reason to think it's more than an abstract possibility, most physicists focus on more immediate or more likely problems. But part of it is also because Kugelblitzes are uncomfortable to think about. They represent a threat we cannot defend against, cannot predict, cannot do anything about. Scientists generally prefer working on problems that have potential solutions. If you can't prevent Kugelblitz formation, if you can't detect it early enough to matter, if you can't stop the accretion once it begins, then what's the point of studying it? What can research accomplish beyond confirming that we're vulnerable and helpless? This is defeatist thinking, but it's understandable. Resources for scientific research are limited. Time and funding go to problems that seem tractable, where progress is possible, where understanding might lead to solutions. Kugelblitzes don't fit that model. They're a worst-case scenario with no obvious mitigation strategy, so they remain largely theoretical curiosities discussed in papers about exotic physics, but not taken seriously as an actual threat to be prepared for. Should we change this? Should we invest more effort in understanding Kugelblitz formation, in developing detection systems, in searching for ways to prevent or stop the process? Probably not, honestly. Given the apparent extremely low probability and the lack of any actionable response, even if we understood it better, Kugelblitz research is hard to justify compared to other uses of limited scientific resources. But that's a calculation based on current understanding. If we discovered evidence that Kugelblitz formation is more likely than we think, if we detected quantum processes in Earth's interior that suggested instability, if anything changed our assessment of the risk, then the calculus would shift. For now, though, Kugelblitzes remain in the realm of extremely unlikely but theoretically possible disasters, like being struck by a meteorite made of antimatter. Could happen, almost certainly won't. Not worth losing sleep over. Almost. Let's think about consciousness again, about what it means to be aware in a universe where such threats are possible. You are a pattern, a temporary configuration of matter and energy that has organized itself into a structure capable of awareness, of thought, of experiencing what it's like to be you. That pattern exists because of specific conditions: temperature within a narrow range, pressure within a narrow range, chemistry following laws that allow for complex molecules and information storage and self-replication. These conditions exist because Earth exists, because it has the right mass, the right distance from the Sun, the right atmosphere, the right geological activity to maintain habitability. And Earth exists because, among other things, it hasn't spontaneously generated a Kugelblitz in its interior over the past 4.5 billion years. That's luck, not design, not protection, not anything earned or deserved, just luck. The quantum fluctuations that could have created Kugelblitzes didn't happen, or happened in ways that didn't reach the threshold, or happened in regions of space far from any planets. Your existence depends on that luck, and so does the existence of every other living thing on Earth. All of life is a 4 billion year run of quantum good fortune, of being in a region of the universe where the right fluctuations happened, creating the initial conditions for life, and the wrong fluctuations didn't happen, creating Kugelblitzes or vacuum decay or other catastrophes. This doesn't make your existence less meaningful, but it does place it in context. You're part of a temporary, contingent, probabilistic phenomenon: life, consciousness, complexity arising from chaos and persisting until something, entropy, catastrophe, quantum fluctuation, ends it. Kugelblitzes are just one of many ways it could end. They're notable because they're so internal, so intrinsic to planetary existence, but they're not fundamentally different from other threats. They all share the same quality. They can happen, they're allowed by physics, and we can't prevent them with absolute certainty. The only difference is where they come from: inside versus outside, self-generated versus externally imposed, but the result is the same: the end of the pattern, the cessation of awareness, the return of organised matter to less organised forms. Let's talk about what we could learn from a Kugelblitz if one were to form and we somehow survived to study it. The physics would be extraordinary. We'd be observing the formation of a black hole from first principles, watching as energy density crosses the threshold into event horizon formation. studying the accretion process in real time. This would answer fundamental questions about quantum gravity, about the behaviour of matter at extreme densities, about the interaction between quantum mechanics and general relativity. Of course, we'd be observing from a doomed planet, so the practical value of this knowledge would be limited. But scientifically, it would be unprecedented. A natural experiment in exotic physics, conducted on a scale we could never achieve artificially. We'd learn about Hawking radiation, whether microscopic black holes really do emit it, at what rate, with what properties. We'd learn about the no-hair theorem, whether black holes really are characterized only by mass, charge, and angular momentum, or whether quantum effects introduce additional properties. We'd learn about information paradoxes, what happens to the information encoded in matter that falls past an event horizon. Does it truly disappear, violating quantum mechanics, or is it preserved somehow, encoded in the Hawking radiation, or in quantum correlations? These are deep questions in theoretical physics, questions we've been debating for decades without conclusive answers. A Kugelblitz would give us answers, though at a cost we'd never choose to pay. This raises an interesting ethical question. If we somehow knew a Kugelblitz was going to form, if we had warning but couldn't prevent it, would we be justified in conducting experiments, in gathering data, in using the catastrophe to advance knowledge? Part of you probably recoils at this. People are dying, civilization is collapsing, and scientists want to take measurements. It seems callous, inappropriate, wrong. But another part might recognize the value. If Earth is doomed anyway, if nothing can save us, then at least we could contribute to the universe's knowledge of itself. We could transmit our findings to other star systems, to any civilizations that might exist there, as a final gift from humanity. We existed. We were conscious. We learned. And here's what we learned about black hole formation and quantum gravity. We hope it helps you survive longer than we did. There's something noble in that, something human. Even facing annihilation, we try to understand, to learn, to pass on knowledge. It's what scientists do. It's what consciousness does. It tries to know, even when knowing can't prevent the inevitable. Let's think about alternatives now, about whether there are any scenarios where a Kugelblitz forms but Earth somehow survives. The honest answer is no. Once a black hole forms and begins accreting in Earth's interior, the process is irreversible with any physics or technology we understand. But let's explore some extremely speculative possibilities, just to be thorough. First, could we feed the black hole something else? Divert its attention, so to speak, give it an alternative source of matter so it doesn't consume Earth? This doesn't work. Black holes aren't selective. They accrete whatever mass is closest to them. If the Kugelblitz forms inside Earth, it's surrounded by Earth's matter, and that's what it will consume. We can't lure it away with external matter. We have no way to position matter inside the planet to intercept the black hole's path. Second, could we somehow eject the black hole from Earth before it grows too large? Also, doesn't work. Black holes are massively dense. Even a small one has enormous inertia. We have no technology capable of applying enough force to change a black hole's trajectory, especially one that's embedded in rock thousands of kilometers underground. Third, could we use the black hole as a power source, harness its accretion energy, somehow make the situation survivable? Theoretically, black holes can be efficient power sources. Matter falling into a black hole releases energy as it accelerates, as tidal forces heat it, as it radiates before crossing the event horizon. This is how quasars work. Supermassive black holes accreting matter and releasing enormous energy. But a Kugelblitz in Earth's core is the wrong geometry. The energy is being released deep underground, not in a controlled environment where we can capture it. And even if we could harness some of the energy, it doesn't stop the accretion. The black hole still grows, still consumes Earth, still eventually destroys the planet. There's no escape, no clever solution, no deus ex machina. Once a Kugelblitz forms inside Earth, we're doomed. And understanding that we're doomed doesn't provide options for avoiding the doom. This is perhaps the purest form of cosmic horror, knowledge without power, awareness without agency, understanding your fate with perfect clarity while being completely unable to change it. Let's talk about legacy again, about what could survive if Earth is consumed by an internal black hole. Physical artifacts obviously don't survive. Everything on or in Earth crosses the event horizon and is lost. The planet's matter, all of its structures, all of its history encoded in rocks and fossils and human-made objects, all consumed. Information might survive if we transmit it before the end. Radio signals, laser communications, messages encoded in various wavelengths, sent toward nearby star systems or out into the galaxy at large. These signals would travel at light speed, spreading outward, potentially reaching other worlds, other civilizations if they exist. The information would persist even after Earth is gone, a ghost of human knowledge propagating through the cosmos. But would anyone receive it? Would anyone understand it? Would it matter? If other civilizations exist and are advanced enough to detect and decode our transmissions, then yes, our knowledge might matter to them. It might help them understand physics better, might warn them about Kugelblitz risks, might let them know they're not alone in the universe, even if they're too far away to ever visit us. If no other civilizations exist, or if they're too far away or too primitive to detect our signals, then the information propagates into emptiness. It exists, it's real, but it has no observer, no recipient, no meaning. Is that still legacy? Does information matter if no one receives it? This is a deep philosophical question, and the answer depends on your metaphysics. Some would say yes, information is real, regardless of whether it's observed, and transmitting human knowledge into the cosmos is worthwhile even if no one ever finds it. Others would say no, meaning requires conscious receivers, and information without observers is just patterns of electromagnetic waves with no more significance than random noise. There's no definitive answer, but there's something poignant about the image of Earth's final transmissions, humanity's last words, spreading outward into the universe, a message in a bottle thrown into an ocean of space and time, hoping for a recipient but not knowing if one exists. Let's drift toward quieter contemplation now, toward accepting the Kugelblitz scenario not as an immediate threat, but as part of the larger context of existence in a quantum universe. Kugelblitzes are extraordinarily unlikely. They require conditions that almost certainly don't occur naturally in planetary interiors. The probability is so low that you could reasonably live your entire life without giving them a second thought. And yet they're possible. The physics allows them. The equations don't forbid them. They exist in the space of things that could happen, even if they almost certainly won't. This is true of many threats: vacuum decay, gamma-ray bursts, asteroid impacts, solar storms, rogue black holes. The list of ways existence can end is long, and most of them are individually unlikely, but collectively they represent a truth. The universe is not obligated to preserve you or humanity or Earth or any structure that emerges from its initial conditions. The laws of physics allow for complexity and consciousness, but they also allow for catastrophe and annihilation. You exist in the gap between these possibilities, between the creative processes that made you and the destructive processes that could unmake you. That gap is narrow, contingent, temporary, but it's real. You're in it right now. And while you're in it, while conditions allow for your existence, you have awareness, you have experience, you have the opportunity to know and feel and wonder. Kugelblitzes don't change this. They're part of the context, part of the landscape of possibilities, but they're not immediate, not pressing, not something that should dominate your attention. Live in the gap. Appreciate it. Experience it fully. Not because it's permanent. It isn't. Not because you're safe. You're not. But because it's real, it's actual, it's happening right now. The planet holds together beneath your feet. The quantum fields remain stable. The fluctuations stay within normal bounds. Today at least, no Kugelblitz is forming in Earth's core. That's enough. That's all you need. Today's stability. Today's existence. Today's awareness. Tomorrow is uncertain. always has been, always will be. Kugelblitzes are just one more item on the list of uncertainties, one more way tomorrow might be different than today. But today is certain. Today is actual. Today is where you exist, where life happens, where meaning is created. Focus there, not on hypothetical quantum fluctuations in the mantle, not on vanishingly improbable catastrophes, but on what's actually present in your experience right now. The ground is solid. The planet is intact. You are here, aware, thinking about these scenarios because you can, because consciousness allows you to contemplate even its own potential destruction. That contemplation is itself remarkable. You're using awareness to understand the ways awareness could end. You're applying consciousness to study unconsciousness. You're being present with thoughts about potential absence. This is what minds do. We think about things that aren't immediate, that might never happen, that exist only as possibilities. We can frighten ourselves with hypotheticals, or we can recognize them as exactly that. Hypotheticals, useful for understanding reality, but not reality itself. Kugelblitzes are useful fictions. They help us understand physics, help us think about probability and quantum mechanics and space-time curvature. But they're almost certainly not forming in Earth's core right now. Almost certainly. Not absolutely. There's always residual uncertainty, always the quantum probability that something unexpected is happening where we can't observe it. But living in fear of vanishingly small probabilities is paralysis, not wisdom. The wise response is acknowledgement without obsession, awareness without anxiety, understanding without fear. Yes, Kugelblitzes are possible. Yes, they would be catastrophic. Yes, we couldn't stop them. And yes, you're alive right now, despite all the things that could have prevented your existence, despite all the quantum fluctuations that didn't happen, despite all the catastrophes that could have occurred but didn't. That's worth appreciating, that's worth being present for. Let's move into the deepest contemplation now, into the space where fear transforms into understanding, where the threat of internal annihilation becomes part of a larger acceptance of what it means to exist in a quantum universe. We've spent time with Kugelblitzes, we've examined the physics, understood the mechanism, contemplated the consequences. We've felt appropriate concern, acknowledged genuine vulnerability, recognized that our planet could theoretically consume itself through quantum processes we can't control or predict. Now, it's time to integrate this knowledge, to find peace not through denial but through perspective, through placing Kugelblitzes in the full context of existence. Start with this. You've always existed on the edge of possibility, not just the possibility of Kugelblitzes, but all possibilities. Every moment of your life depends on conditions remaining within the narrow range that allows for consciousness, for life, for the complex chemistry that creates awareness. Those conditions are maintained by countless processes, each of which could potentially fail. Your heart could stop, your brain could hemorrhage, a blood clot could form, an aneurysm could burst. Any of these would end your consciousness instantly, without warning, without the possibility of prevention, if the underlying cause is already present. You live with these vulnerabilities every day without constant fear, because you understand at some level that existence is inherently precarious, that being alive means being vulnerable, that consciousness requires conditions that are temporary and fragile. Kugelblitzes are just this same truth scaled up to planetary level. Earth exists on the edge of possibility, maintained by physical processes that could theoretically fail, that could spawn catastrophic consequences from quantum fluctuations we can't predict or prevent. But Earth has existed for 4.5 billion years without this happening. Your body has existed for decades without catastrophic spontaneous failure. The conditions that allow for existence are narrow, but they're also remarkably stable within their range. Stability isn't permanence, but it's enough for life to emerge, to evolve, to become complex, to achieve consciousness. It's enough for you to be here now, thinking about these scenarios. That's remarkable. Not safe. You were never promised safety, but remarkable. Let's think about what Kugelblitzes tell us about the nature of reality itself, about the relationship between the possible and the actual. Physics is written in the language of possibility. The equations describe what can happen, not what must happen or what will happen. They define boundaries, events that cannot occur because they violate fundamental laws. But within those boundaries, many outcomes are possible. A Kugelblitz is possible. The equations allow it. There's no fundamental law forbidding the spontaneous concentration of energy to black hole-forming densities. It's just extraordinarily, vanishingly, almost impossibly unlikely. But almost impossible means it lives in the realm of the possible. It exists as potential, as a path reality could take, even if it almost certainly won't. This is true of everything. Your existence was possible but extraordinarily unlikely. The specific arrangement of atoms that creates you, the specific sequence of events that led to your birth, the precise conditions that allowed life to evolve on Earth, all possible but improbable. And yet here you are, the improbable made actual, the possible made real. Kugelblitzes are the inverse. The possible that remains merely possible, the potential catastrophe that doesn't actualize. And for your existence to continue, for consciousness to persist, countless other catastrophic possibilities must also remain unactualized. You exist in a narrow channel through possibility space, a path where the life-supporting possibilities actualize and the life-destroying possibilities don't. This channel is not carved by design or protected by intent. It's just the path you find yourself on, the trajectory that led to this moment of awareness, and that trajectory could end at any moment, from countless causes, both internal and external, both biological and physical, both likely and unlikely. Kugelblitzes are just one item in an infinite catalogue of ways the trajectory could terminate. They're notable because they're so strange, so internal, so quantum mechanical. But they're not fundamentally different from any other threat. They're all expressions of the same truth. Existence is contingent, temporary, vulnerable. The question is not how to eliminate this vulnerability. You can't. The question is how to live fully despite it. Let's talk about meaning one more time, from the deepest possible perspective. If Earth were consumed by a Kugelblitz tomorrow, if all of human civilization disappeared past an event horizon, would our existence have mattered? The universe wouldn't notice. Stars would continue burning. Galaxies would continue rotating. The fundamental laws of physics would continue operating exactly as before. The absence of humanity would change nothing at cosmic scales. Does that mean we don't matter? That our consciousness, our civilizations, our art and science and love are cosmically insignificant? One answer is yes. In the vast scheme of things, in the context of the entire universe across all of time, we're negligible. A brief flicker of complexity on one small planet, irrelevant to the grand cosmic story. But there's another answer. Deeper answer. Mattering isn't something the universe does. Mattering is something consciousness does. You matter because you're aware enough to care, to evaluate, to create meaning through your awareness. The universe doesn't care about you, but you care about the universe. You care about yourself, about others, about beauty and truth and understanding. And that caring, that capacity for meaning-making is real even if the universe doesn't reciprocate it. A Kugelblitz can end your consciousness, but it can't erase the fact that consciousness occurred, that meaning was created, that for a brief time the universe contained beings who could care about it and about themselves. This is perhaps the deepest possible response to existential threats. Meaning doesn't require permanence or cosmic acknowledgement. It requires only consciousness and the capacity to care. And as long as consciousness exists, meaning exists with it. When consciousness ends, whether from individual death, planetary catastrophe, or universal heat death, meaning ends too. But that doesn't retroactively erase the meaning that existed. It just means that meaning, like consciousness, is a temporary phenomenon. Temporary doesn't mean unreal, it means finite. And finite things can still be valuable, still be worth experiencing, still be the most important aspect of existence from the perspective of those who experience them. Let's think about the relationship between knowledge and peace, about how understanding threats can paradoxically make them easier to live with. Before you knew about Kugelblitzes, you were vulnerable to them without awareness. Now you know about them, and you're still vulnerable, but you have understanding. Has this knowledge made you better off? Has it increased your well-being to know about this extraordinarily unlikely, but theoretically possible catastrophe? In one sense, no. You've added a new item to your catalogue of things to potentially worry about. You've introduced a concept that could trigger anxiety, could make you view Earth's stability with less confidence. But in another sense, yes. You've deepened your understanding of physics, of probability, of the nature of existence in a quantum universe. You've confronted a threat directly, examined it from every angle, and arrived at the conclusion that while it's real, it's not worth constant fear. This is the pattern with all existential threats once you understand them fully. Initially, they're terrifying. Unknown dangers are always the scariest. But as you learn more, as you understand the mechanisms and the probabilities, they become less emotionally charged, not less real, not less dangerous, but less overwhelming because they're no longer mysterious. You know what you're facing even if you can't prevent it. There's peace in that knowledge, not the false peace of believing you're safe, but the real peace of understanding reality as it is, accepting it and choosing to engage with life despite the understanding. You know Earth could theoretically spawn an internal black hole. You know you're vulnerable to quantum catastrophes you can't predict or prevent. And you can live fully anyway, can create and love and experience, because understanding doesn't require control, and peace doesn't require safety. Let's talk about the gift of the present moment one more time, because it's the ultimate response to all existential threats, including Kugelblitzes. The past is immutable. Whatever happened, happened. No Kugelblitz can change the past. Your experiences, your memories, your actions, they're permanent in the sense that they occurred. They were real. They shaped reality. The future is uncertain. Always has been, always will be. Kugelblitzes are just one source of uncertainty among countless others. You don't know what tomorrow brings, have never known, will never know until tomorrow becomes today. The present is all you directly experience, this moment, this awareness, this breath, this thought, this sensation of being alive right now. And in this present moment, no Kugelblitz is consuming Earth. The planet is stable, the quantum fields are within normal parameters, you exist, you're conscious, you're capable of experiencing and understanding and creating meaning. That's enough. That's everything. Tomorrow might be different. Tomorrow a quantum fluctuation might occur, or an asteroid might impact Earth, or a solar storm might destroy our infrastructure, or you might die from any of the countless causes that end individual consciousness. Or none of these might happen. Tomorrow might be much like today. The threats might remain unrealized. The narrow channel through possibility space might continue for another day, another year, another lifetime. You don't know. You can't know, and that's okay. Not knowing the future is part of what it means to be conscious in time, to experience existence sequentially, to not have access to all moments simultaneously. What you have is now, and now is sufficient. Now is where awareness happens, where experience occurs, where meaning is created. Live in now, not in fear of hypothetical futures, not in regret about immutable pasts, but in the actual present, the only time that's real in your direct experience. The Kugelblitz might form tomorrow, or never. It doesn't matter to this moment. This moment is what it is, an instance of consciousness, an experience of awareness, a brief flicker of the universe knowing itself through your particular perspective. Let's think about consciousness one final time, about what a privilege it is to be aware at all, even in a universe where awareness is temporary and vulnerable. Most of the universe is not conscious. Most matter doesn't experience, doesn't know, doesn't mean anything to itself. Stars burn without awareness. Galaxies rotate without understanding. Black holes consume without experiencing. Consciousness is the exception, not the rule, and you're part of that exception. You're one of the rare regions of the cosmos that can experience, that can know, that can wonder about its own existence and its potential endings. This is extraordinary, not because it's permanent, it isn't, not because it's protected, it's not, but because it exists at all, because the universe can produce configurations of matter that achieve self-awareness, that can think about things like Kugelblitzes and quantum mechanics and the meaning of existence. A Kugelblitz could end this, could end all consciousness on Earth, could erase every human mind, could convert the substrate of awareness back into unconscious matter, compressed past an event horizon. But it hasn't happened yet. And in the time before it happens, whether that's tomorrow or billions of years from now or never, consciousness exists, awareness occurs, meaning is created. You're part of that. You're contributing to the universe's self-knowledge, to the total sum of awareness that has existed, and that contribution is complete in each moment, doesn't require continuation to be real. When consciousness ends, whether from individual death or planetary catastrophe, the universe returns to being mostly unconscious. But the consciousness that occurred was real. The awareness that existed mattered. The meaning that was created had value, even if that value was appreciated only by other temporary, vulnerable conscious beings. Let's move towards silence now, toward the quiet acceptance that comes when understanding becomes wisdom, when knowledge settles into peace. You know about Kugelblitzes, you understand the physics, you've confronted the threat directly, examined it thoroughly, felt appropriate concern about its implications, and now you can let it go. Not forget it. It's part of your knowledge now, part of your understanding of the universe. But release it from the center of your attention. Let it settle into the background where it belongs. Alongside all the other unlikely but possible catastrophes, the Earth holds together beneath your feet, has held together for billions of years. The quantum fluctuations have remained within normal bounds. The energy densities have stayed below the Kugelblitz threshold. Today at least you're safe. Today the planet is stable. Today consciousness persists. And today is all you ever really have, all you ever really need. Tomorrow is not promised. But it never was, never has been for anyone, regardless of Kugelblitzes or any other threat. The uncertainty is fundamental to existence. You can't eliminate it. You can only choose how to relate to it. You can live in fear, constantly anxious about all the ways things could go wrong, all the quantum fluctuations that might occur, all the catastrophes that might strike. Or you can live in presence, aware of vulnerability but not defined by it, understanding the threats but not obsessed with them, accepting uncertainty while still engaging fully with the actual present. The second way is wisdom. The second way is peace. The second way is how you live fully in a universe that contains both consciousness and the countless ways consciousness can end. Be at peace with the quantum nature of reality, with the fact that events at scales too small to observe can have consequences at scales large enough to destroy worlds, with the understanding that stability is statistical, not absolute, and that even stable systems can fluctuate into catastrophic states. This is how things are. This is how they have always been. This is the universe you inhabit, quantum, probabilistic, allowing for both the emergence of complexity and its destruction. Accept it. Not with resignation, but with clear-eyed recognition. This is reality. And reality, even with its threats, even with its fundamental uncertainty, is worth experiencing. Sleep now or wake, or continue your day. carrying this understanding lightly. The Kugelblitzes remain unformed. The quantum fields remain stable. The planet holds together. For now, for this moment, for as long as possibility continues to favour existence over annihilation. And in that favour, in that temporary stability, there's life to be lived, awareness to be experienced, meaning to be created. Do that. Be that. Experience that. For as long as the universe allows, for as long as consciousness persists, for as long as the quantum fluctuations remain benign. The planet and the consciousness it supports, existing together in the vast emptiness of space, both temporary, both vulnerable, both extraordinary. Be grateful for it. Not despite the vulnerability, but including it. The whole package, the complete reality, the consciousness and the planet and the quantum fields and the possibility of Kugelblitzes and the actual absence of Kugelblitzes right now. All of it together, real and valuable and worthy of full engagement. This is what existence offers, awareness in the face of uncertainty, consciousness despite vulnerability, meaning created from temporary configurations of matter that know they're temporary. Take it, all of it, with open awareness and full presence, and live. The quantum fields fluctuate beneath you, mostly harmlessly. The energy densities remain within normal bounds. The planet continues its ancient rotation around a stable star. You continue your brief existence as a conscious being, aware of the universe and aware of your awareness, creating meaning in the space between emergence and dissolution. That's enough. That's everything. The Kugelblitz remains unformed. The consciousness remains aware. And in that awareness, brief and fragile and vulnerable as it is, the universe achieves something extraordinary. It knows itself. It experiences itself. It creates meaning from its own existence. You are that knowing. For now. For this moment. For however long now continues to be. Rest in that knowing. Not in false promises of permanence, but in the reality of present awareness, present experience, present existence. The planet holds, the consciousness persists, the quantum universe allows for this moment of stability. Be here for it, fully, completely, without reservation or distraction, for as long as it lasts, which is always only now, which is always enough.